This is Dr. Shankaraiah from Department of Physics. In this presentation, I am going to discuss about the definition and terminology on Module 2, Quantum Mechanics. So the first definition is, what is quantum mechanics? Quantum mechanics is a branch of physics dealing with the behavior of matter and light on the atomic and subatomic scale. What is classical mechanics? It is a branch of physics that is based on Newton's laws of motion and that is applicable to systems that are large macroscopic system, whereas quantum mechanics can deal with atomic and subatomic scale. So that is the difference between quantum mechanics and classical mechanics. What is a black body? An ideal body or surface that completely absorbs all radiant energy falling upon it with no reflection and that radiates at all frequencies with a spectral energy distribution. Black body can absorb all the radiation falling it, and if we eat the black body, it is going to emit all the radiation that is absorbed. What is photoelectric effect? A phenomenon in which electrons are ejected from the surface of a metal when light is incident on it. So these electrons are called photoelectrons. What is de Broglie's wavelength? The wavelength that is associated with an object in relation to its momentum and mass is known as de Broglie's wavelength. So de Broglie wavelength lambda is equal to h by m into v. A particle's de Broglie wavelength is usually inversely proportional to its force. Okay, so yeah, so lambda is inversely proportional to momentum, and we can write force in terms of momentum. That is why we are saying inversely proportional. Define momentum of a particle. Momentum is product of mass and velocity. Is a vector quantity. It has both magnitude and direction. State how Einstein theory of relativity gives energy in terms of mass of the body. Giving an equation E is equal to mc square, Albert Einstein theory of special theory relativity expresses the fact that mass and energy are the same physical entity and can be changed into each other. So you can energy can be written as E is equal to m into c square, where m is mass. So you can convert mass and energy. So energy and mass are same. That is what Einstein proposed, and in his equation E is equal to mc square, and it can convert from mass and energy are the same entity and can be changed into each other. So that is what theory of relativity gives energy in terms of mass of the body. Give Planck-Einstein relation of energy E and frequency. Einstein defined a quantized unit or quantum of electromagnetic energy, which is called as photon, with an energy proportional to the frequency of electromagnetic radiation. In equation form, photon energy E is equal to h nu, where E is the energy of a photon and frequency nu is the frequency, and h is a Planck's constant. So this is the Max Planck relation in terms of energy and frequency. E is equal to h nu. Define wave vector k. A vector indicating the direction of wave propagation and the phase delay per unit length is wave vector, and it is always perpendicular to the wave fronts. Its magnitude is the wave number as defined by k is equal to 2 pi by lambda. So this is the wave vector k, which is 2 pi by lambda. Lambda is the wavelength. What is h? Give its value. H is Planck's constant, and which is a natural constant named after Max Planck, and its value is approximately 6.63 into 10 power minus 34 joule second. What is h bar? H bar is nothing but h by 2 pi. Okay, so a modified form of Planck's constant called h bar, or the reduced Planck's constant, in which h bar equals to h by 2 pi is a quantization of angular moment. What is wave function psi? It is a function which gives all the information that there is about a quantum system. Okay, so wave function gives all the information about a quantum system. A quantum system can be one or many particles. Basically, wave function gives more information about the particle, and which constitute a quantum system. Why de Broglie wave associated with a moving car is not observable? Why de Broglie wavelength is not observable for macro systems, and why only for micro systems? We know that lambda is lambda is equal to h by m into v. So lambda is inversely proportional to velocity and mass right? So since m is very large for a car, therefore lambda is very small. Consequently, de Broglie wavelength associated with moving car is not observable. Because m is large, lambda will be very, very small, and we cannot detect such small wavelengths. What is the rest mass of a photon? Planck's radiation law states that energy is radiated in the form of a wave packets, and this energy packet has both wave and particle character. Okay. Are matter waves electromagnetic waves? No. This is because electromagnetic waves are produced by accelerated charge. On the other hand, de Broglie wave is independent of the charge of a particle. What is the difference between light waves and matter waves? The velocity of light wave in vacuum is a constant quantity. On the other hand, velocity of matter waves in vacuum depends on the wavelength. Comment on the statement. Heisenberg's uncertainty principle is valid for all kinds of particles. Heisenberg's uncertainty principle is valid for all kinds of particles. For the atomic particles, there is always some uncertainty in the measurement of two conjugate quantities like position and momentum, angular position, angular momentum, energy and time. But for the particles of large size, this uncertainty is very small as compared to the value of h, the Planck's constant, and hence uncertainty is not observable for macro particles or large size particles. Heisenberg uncertainty principle is valid only for small particles, micro particles. Describe Compton wavelength. The Compton wavelength of a particle is equal to the wavelength of a photon whose energy is same as the mass of the particle. Okay, so Compton wavelength is equal to the wavelength of a photon. Explain about Compton effect. Compton effect is the increase in the wavelength of X-rays and other electromagnetic radiations that have been elastically scattered, and it is a principal way in which radiant energy is absorbed in the matter. So in the Compton effect, we will find that there is an increase in wavelength of X-rays. We have incident X-rays, and we find that the wavelength of the X-rays increased, and because of the elastic scattering. Define the matter waves. Matter waves, the waves associated with particles of matter, example electrons, protons, etc., are known as matter waves or de Broglie waves. Is light made of particles or of waves? Light exhibits both the behavior of particle and wave. What is a system in quantum mechanics? A quantum system is any collection of physical objects that is to be described by a wave function. What does the electromagnetic wave contains? The electromagnetic wave contains both electric fields and magnetic fields which are perpendicular to each other. Define wavelength. The wavelength is the spatial period of a periodic wave, the distance over which the wave's shape repeats. Okay, so if you need to this is one wavelength lambda. Okay, so it is the distance between consecutive corresponding points of the same phase on the wave. Okay, how is the wavelength related to the mass of a particle according to de Broglie's relation? Okay, so lambda is equal to h by m into v. According to the de Broglie, the lighter the particle, the greater the wavelength associated with the particle, because lambda is inversely proportional to m. If m is small, lambda is large. If m is large, lambda is small. State Bragg's law. When a monochromatic X-rays are incident upon a crystal, atoms in different layers acts as a source of scattering radiation of same wavelength. The intensity of the reflected beam will be maximum at certain incident angle when the path difference between two reflected waves from two different planes is an integral multiples of wavelength of X-rays. Actually, Bragg's law is 2d sin theta is equal to n into lambda. Okay, where theta is the diffraction angle, d is the interplanar spacing, lambda is the wavelength of the incident radiation. So yeah, so this equation is defined here. Okay, what is wave particle duality? An idea that light and subatomic particles can behave both as waves but also as particles. Wave particle duality means that light radiation, for example, has both behaviors, particle behavior as well as wave behavior. Similarly, matter also has both behaviors. Matter can behave as particle, matter can also behave as wave. Okay, so both radiation has two behaviors and matter also has two behaviors. So that is why it is called as wave particle duality of radiation and matter. What is the principle used in division and Germer experiment? Beam of electrons is allowed to fall on a nickel crystal. Atoms of nickel causes diffraction of electron beam at different angle. Thus, the underlying principle of experiment is to observe diffraction of effects of electron beam to study wave nature of electrons. So basically, in Davison and Germer experiment, you have electron gun that shoots electrons onto this nickel crystal, and these electrons are scattered in different angles. You have a rotating scale where you look at the scattering angle, and we will calculate the de Broglie wavelength using Bragg's equation as well as de Broglie's equation. Both of these, we find that the lambda from Bragg's equation and lambda from de Broglie's equation matches very well. That means that only waves can have diffraction, but here we are using electrons. Okay, so we prove that electrons also behave as waves because the wavelength calculated using Bragg's equation is matching with the wavelength calculated with de Broglie's equation. What is a potential box? In quantum mechanics, the particle in a box model, also known as infinite potential well or infinite square well, describes a particle free to move in a small space surrounded by impenetrable barriers. What is normalization condition? The probability per unit length of finding the particle at position x at time t is 1. So that is probability of finding the particle per unit length is 1. What will be the velocity of matter wave? Matter wave can travel with more than the velocity of light. Define energy spectrum. The energy spectrum refers to the possible energy of a system. For bound system, the energy spectrum is discrete. For unbound system, the energy spectrum is continuous. So if we solve the particle in a 1D box, we will find the energies are discrete, where the particle is bound in a box. For unbound system, the energies are continuous. Define eigenvalue and eigenfunction. Eigenvalue is defined as energy of the particle and is denoted by the energy letter En. Eigenfunction is defined as the wave function of the particle and is denoted by the letter psi n. So eigenvalue and eigenfunctions are nothing but energies. So eigenvalues are nothing but the energies of a particle confined in a potential box, and eigenfunctions are nothing but the wave functions of the particle confined in one-dimensional box. What are the assumptions for the region in which the particle is in a potential box? The particle cannot exist outside the box as it cannot have infinite amount of energy. Thus, its wave function is between 0 and L. If we are confining the particle in a box of length L, the particle is trapped in this box. It cannot escape this box, and hence the wave function will be only inside this box, because the wave function tells us about the probability of finding the particle in a given length, given region of space. Okay. Define principal quantum number. In quantum mechanics, the principal quantum number is assigned to each electron in an atom to describe that electron state. Its values are natural numbers from 1, making it a discrete variable. Principal quantum number is a discrete variable. Define angular frequency. Angular frequency is a scalar measure of rotation rate. It refers to the angular displacement per unit time. Angular frequency is angular displacement per unit time. What is Schrodinger's wave equation? Schrodinger wave equation is a mathematical expression describing energy and position of the electron in space and time, taking into account the matter wave nature of the electron inside an atom. Schrodinger wave equation is in one dimension is dou square by dou x square plus 2m into E minus B by h cut square into dou square psi by dou into psi is equal to 0. So this is Schrodinger one dimension wave equation in time independent wave equation in one dimension. So it will tell us about it basically describes the wave function psi in a given region of or space where the particle is trapped. V is 0 inside, V is potential, that is 0 inside and infinite at the boundaries. So it describes about the psi Wave function describes about the psi, and so psi is basically wave function. So that tells us about the probability of finding the particle in a given space. Define momentum. Momentum is a product of the mass of a particle and its velocity. So basically P is momentum, which is product of mass into velocity, and is a vector quantity. Isaac Newton's second law of motion states that the time rate of change of momentum is equal to the force. So that means F is equal to m into A or m into dp by dt. Okay, so yeah, so dp by dt, because P is equal to mv. So yeah, so dv by dt is A and you will get ma. So F is equal to ma or F is equal to dp by dt. The time rate of change of momentum is equal to the force acting on the particle, and this is Newton's second law of motion. Define the term quanta according to Max Planck. Max Planck postulated that electromagnetic energy is absorbed or emitted in discrete packets called quanta. So energy can be energy can be absorbed or emitted only in terms of packets, discrete packet, and each packet carries an energy E is equal to h into nu, and this packet is called as quanta, okay, which is named as photon by Einstein to explain photoelectric effect. Define the term photon. A particle representing a quantum of light or the other electromagnetic radiation. A photon carries energy proportional to the radiation frequency but has zero rest mass. So that is what E is equal to h into nu. So the energy is proportional to the frequency of the radiation, but it has zero rest mass. So this is photon. So these are the 40 definitions in module 2. These are some of the textbooks I used and references books here. And to summarize, in this presentation I have discussed the definition and terminology of module 2, which is quantum mechanics in applied physics course. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.